Okay, so today we're doing difference of squares. So when we gave this to you last week, we had two binomials with that looked the same with a different sign. We know that the outer and the inner terms ended up getting canceled. So the first one would be x squared minus 9. Pause the recording and try the next few. Now check your work. Okay, every time we're noticing that the middle, inner, and outer term are disappearing. So, and that is because the inner term is positive 3x, the outer term is negative 3x, and they are additive inverses. So they end up negating each other. Okay, so here we go. Let's go on to the next part. So now we're starting with our product, whereas before we were given two factors and we had to look for the product. This entire chapter, we're starting with the product and you have to look for the factors. So what are the two factors that make up x squared minus 9? Now, when you have this pattern, I know I asked a question, but when you have this pattern, it's super easy. I want you to make, it comes when you have a binomial, a perfect square minus a perfect square. We call it a difference of squares. So I want you to make two parentheses. It's super easy. What's the root of the first term? Yep. The root of the first term? X. X. So I place it here and here. What's the root of the second term? What's the root of the second term? Andy? 3. 3. 3 and 3. And now, if it's a binomial and two perfect squares, I add a plus sign and a minus sign. Super easy, right? So I want you guys, well, let's start going around and doing this. Caleb, number 2. Number 2 would be?
Number 2 would be m plus 7 and m minus 7.
Good. Okay, number 3, please. Y plus 10, y minus 10. Number 4, please, Trent.
C plus A and C minus A.
Got it. Number 5, Michael.
X minus y and x plus y times x minus y.
That sounded like 3 of them. X plus y times x minus y. Okay. Okay, number 6. We're going to keep it in the order that it's given, Sean. So it'd be?
4 minus k times 4 plus k.
Perfect. Next one.
B plus 1, p minus 1.
Perfect. Okay, so before we did the greatest monomial factor, you've got a chart right over here, and I want you to follow it. You know, it kind of gives you the directions on what to do. We start with a problem. We look for a GCF. If there's no GCF, what am I left with? A binomial, trinomial, or more than 3 terms? Anything else? Okay, if I'm left with a binomial, the only thing factorable is a difference of squares. So here we are with our difference of squares, number 2 pattern. So remember, a difference of squares is a perfect square, different sign, perfect square. That's how we tell it goes to this pattern. Okay, questions there? No, we're not going to have time to do it all. Okay, so let's talk about our perfect squares. I want you to list them. Actually, our first perfect square starts with, yep,
1.
or before that, 0. Okay, but I guess you're right. We have to start with 1. So 1 is a perfect square. What's the next one? 2, which would be? 2 is not a perfect square. 4. Okay, we've got 4. 1. We have 4. What's next? Next. Next. 36. 64. Everybody. Okay, stop. You should already have learned those in 4th grade. These are numbers that are going to come up the rest of your mathematics education. You need to have them memorized 221. Okay? What would 13 squared be?
169.
Okay. 196, 14 squared, 225. Whoops. We're going to keep going. I want yours memorized through 2025 because this is going to be a time saver. I learned 2 of them today. So 14 squared is this. 15 squared is 225. 16 squared is 256. 17 is 289. Whoops. That's a 9. 18 squared is 324. 361 is 19 squared. 400 is 20 squared. 21 is 441. 22, these are the new ones I learned today. 484. 23 is 529. Doesn't look like a perfect square. 576 is 24 squared, and 25 squared is 625. You need those memorized. Those numbers are going to come up factoring all the time. And if you have to sit there and go and try and figure out what the root of 529 is, it's going to take time and you're not going to finish your test. Am I clear? So go home and memorize this. Okay. So we talked about, whoops, number 1. Where did we leave off at? Michael, was that? No, that was you. Okay, Chris. Number 1. Perfect. And number 2. Oh. So what would number 2 be on Sana?
3m minus 11 times 3m plus 11.
Perfect. Okay, I want you to pause the recording and finish the rest. So number 3, where did I leave off? Okay, Valerie?
K squared plus 2 and
No, keep it in order.
4 plus 7k times 4 minus 7k.
Perfect. Okay, whoops, it always does that. Okay, next one, let's go to Berenson.
K squared times k squared, or k squared minus, or, I'm sorry, k squared plus 2 times k squared minus 2.
Yeah, and when I do these, I generally put the plus sign on the left for a reason. You don't have to, but later it's going to matter. Stop. Okay, next one, number 5. Let's go, Sophie.
I didn't get number 5.
Connor? Not factorable. Why, Connor?
Because 50 is not a perfect square.
50 is not a perfect square. I said you had to have perfect square, different sign, perfect square. It's not a perfect square. So we can't factor that. They don't have anything common. We can't GCF. We can't do anything. So we're going to say what?
Cannot be, not factored.
Number 1 most overused word in all of algebra from here till the last day you're with me. Now, every time it gets hard, do not throw a not factorable in, please. Work your way through, learn your perfect squares, and stop using not factorable, but it is not factorable. Okay, number 6. T, what'd you say? Huh? Do not. No. No. Okay, next one. 4x squared minus 49. 4x squared minus 49. Olivier?
It is 2x minus 7 and 2x plus 7.
Perfect. And next one, let's go. Wait, who was I? I was going in order. Okay, let's go with Una. Hold on 1 second. What happened here? Okay, Una, go.
6y plus 1 times 6y minus 1.
Perfect. And then the last one, Michelle.
I got 4x plus 5
Times
4x plus 5.
4x plus 5 times 4x plus 5. Let's try that. 4x plus 5 times 4x plus 5. So I get 16x squared. I get 25, and I'm going to, please stop talking and humming. 20x and 20x. Inner and outer, No, that's not going to be, that's going to be 16x squared plus 40x plus 25. So what are you saying? Boeing, what do we say?
Not factorable.
Not factorable. Why, Boeing?
Because there's no minus sign between them.
Yeah, it is a sum of squares, not a difference. I told you the only binomial that is factorable is a difference of squares. And if you look right on the board, I have it outlined in red where there's a sum of squares and it says not factorable. So there's your reminder, there's your cheat sheet. Okay? Not factorable. Okay, so next. So now we're not going to just forget what we learned yesterday. We're now going to use it together. So every time we look at a problem, the first step we're going to do is we're going to GCF it. What is the GCF here? Anybody? 2. Okay, so we're going to do a 2. And when I divide 2 out, I'm left with x squared minus 25. Now what? Now what? How about Justin? What do you think? What would I do with x squared minus 25? What can I do with it? Okay, let me go to Chris. What would I do with x squared minus 25?
It would become x plus 5 times x minus 5.
Yeah, and I keep the 2. 2 times x plus 5 times x minus 5. Okay? So this is what, oh, sorry, I didn't mean to do that. We have to factor completely. If you leave it like this, everybody, if you leave it like this, I would say it's not factored completely because you are left, Gavin, with a difference of squares. You are left with a difference of squares. Am I clear? Okay, you have to factor completely. Okay, next one, m to the 4th minus 1. You want to try this one on your own? Try it. Pause the record. Olivier, remember I told it, when m's recording, guys. Remember I told you when you have a perfect square minus a perfect square, you are to make, right? Yeah. What's the root of m squared? What times itself equals m to the 4th?
Squared.
Yep. What's the root of 1?
1 and negative 1.
So I'm going to do plus and minus. But what am I left with? What is this called? So I have to factor completely. Okay? So I'm going to write the original one, m squared plus 1 times what? What's the root of that?
Minus 1.
What? What's the root of that?
M.
Root of that.
1.
And what am I going to write? Plus 1 minus 1. Got it? Questions? All right. Yes.
What's the difference for when you do GLF and then difference of squares, or when you just do difference of squares?
Well, in this one, there was no greatest monomial factor or greatest common factor. It's always the first thing we check. If you don't pull it out, I promise you're going to end up being left with something like I'm trying to say minus 81. No, that wouldn't work. I promise you're going to end up being left with something left in there that still needs to be factored out. We'll encounter it a little bit later. So you always want to check for a difference of square. I mean, that you fully factored everything. You start with, I do want to talk about what happens if when you're taking the root of like m to the second, that's a perfect square. But let's say I have 9m. That's not a perfect square term. This is a perfect square. Look up here. This is a perfect square, but m is not. So you can't take the root of that. Okay? If I have 9m squared, that's a perfect square. Perfect square, perfect square. If I have 9m to the third, m to the third is not a perfect square. But 9m to the fourth is. It has to be 9m to the fourth, 9m to the sixth, 9m to the eighth. It has to be an even amount. And we basically just divide it in two. Because what number times itself equals m to the sixth? M to the third times m to the third. Remember, when we're multiplying exponents, we really add them. So just divide those exponents by 2. Yes?
If you have something like m squared times, or subtract, or minus n to the, or nm, could you just factor
M squared minus mn. Now, in this case, we would have to GCF first, right? And then I'm left with, what if we had this? Okay, are you with me?
Yeah.
Step 1, oh, it's not even going to help. It would have to be this. If it was m to the third, so if I factor out GCF, what is it?
m,
Just an m. Then I'm left with m squared minus n squared.
which is a perfect square.
A difference of squares. M squared times m minus n times m plus n. All right, let's do a little bit more. Sorry, I gotta erase. There we go. Okay, step 1, what would happen, guys? Step 1. Okay, Olivier?
What would happen is that we would have to factor it by 3.
Because we need to do our GCF, right.
Yes.
And so it would be 3 times?
3 times y squared
Mi-
minus 9.
Okay,
And both are perfect squares.
no. Oh, in the binomial. Okay, so now what would happen next, Rashmia?
Maybe 3 times y times
No, y.
minus 3 times y plus 3.
That's correct. Y minus 3 times y plus 3. Okay, questions? Not sure why it's having such a hard time. Oh my gosh. All right, now let's do number 2. Number 2. Let's go Schweib.
So first you have to do a difference of squares. So it'd be x squared minus 9 times x squared plus 9.
Good. I always put my plus on the left so I can build out my difference of squares.
So x squared plus 9 times x squared minus 9. And then you can do another difference of squared for x squared minus 9.
But what would my final answer be?
X squared plus 9 times x plus 3 times x minus 3.
Are you guys with me? Okay. So look for more. Always look that you're factoring completely. Next one, number 3. Number 3. Ansana?
You would factor out the 5, so it would be 5 times the quantity of m to the 6 minus 4.
Good.
And then you would simplify it would be 5 times the quantity of m to the third minus 2 times m to the third plus 2.
Perfect. Next one, what am I doing? What am I doing? Let's go with, okay, Connor,
You can factor out a 5.
of a GCF of 5. Call it what it is. Okay, then factor the difference of squares. What am I left with?
5 times the quantity of y squared minus 4 times the quantity of y squared plus 4.
Good. Are we done?
No.
No, because we're left with another difference of squares. So what would it be, Connor?
5 times the quantity of y plus 2 times the quantity of y minus
No. No, you're forgetting the first one. Don't forget your first 5 times the quantity of what?
2. Y plus 2.
Nope, you forgot about that. 5 times the quantity of what?
Y squared
Plus
4 times the quantity of y squared minus 4.
No. You're not making sense. So, let me grab. We're doing 5. I've got y plus, please freeze. Y plus y squared plus 4, and then this is,
y plus 2, y minus.
yes, y minus 2. You kept saying 4.
Yeah, sorry.
And that is the lesson.